Okay, so 1-10, which is the last unit that we're going to do. Next time is review. Once again, if you need to grab a review, it's back on the back. Walk out. Get it over. Okay. If you don't grab it if you're going to be here, because that's all you're going to do in class next time is work on the review. So, everybody make sense? Here we go. So, what are some functions you guys have already studied in the past? Nobody. You haven't studied any functions in your whole life. Would you study all of last year primarily? Which is a quadratic, huh? Didn't you guys learn how to graph quadratics by finding their vertex, by completing the square, by doing all these other types of things, right? Okay. What's the basic? This is our basic function, just x squared. What does it look like? How can I tell what it looks like? Well, if I plug in -2, -1, 0, 1, and 2, those are what I call my Fab Five. Meaning, if I plug those in, I get a basic graph of what he looks like, which is just a parabola, right? Parent function. Everybody there with me? Any questions on how I found these values? Where did I find these guys? I randomly picked them. Why did I pick this number? Because there's some negative numbers. Why did I pick him? Y-intercept. Why did I pick these guys? Some positive numbers. Why did I not go bigger than that? Because that's a lot of freaking tick marks. Okay? You don't want to go more. Okay, what's another function you guys studied? Please help me so I can go through this quicker. X cubed is something we've done. That's more this year. Remember, we've studied that. Looks like that, but it should be prettier than that, but you get the idea, right? What values did you plug in? Probably the same things. These are still nice values, aren't they? Could I pick 4 if I wanted? So what's 4 cubed? 64. That's a big honking number, huh? Do we really want to play with him? No. So, hence, where these are coming from. Any questions there? Give me another one. How about, have you guys ever studied linears? Who can we plug in for him? Still the same things, right? Okay. Anybody else? How about an absolute value graph? You guys did that before. What do they look like? Don't they look like a V? Okay. What's some nice values to plug into that? Same thing still, right? Still can use my Fab Five, correct? He looks like a V. What else? How about a square root? Maybe you haven't done that one, but we're going to talk about that one. What value should I plug in for a square root? Can I do my Fab Five? No, because I can't really put -2 in there. Then I get imaginary, so I just want to drop real. Can I pick 0? Yeah, what's the square root of 0? What else can I pick? 1's a good one. How about 2? I could. Why do I want to pick him though? Not perfect. So who's probably next? 4 and 9, right? You guys agree with that? Could I pick 7? And then what's the result? Square root of 7, and then I got to plot square root of 7, and I'm like, no. Right? What do you guys think? What else? What else? What else? What else? I could do 16, but I'm not. How about the cube root of x? Who goes into the cube root of x? 0's a good one. 1's a good one. 8's a good one. -1's a good one. -8's a good one. Okay, I just gave you, if you don't have them written down, I'd suggest you write those 6 down. Those are 6 parent functions. Quadratic, cubic, linear. have your band family Monday. Okay, those are the family. Those are your parents. Now, what do I mean by a parent function? A parent function is what we start from. We come from our parents, right? Meaning they're going to give us a little bit. So here is what I'm going to ask you guys to graph at the very beginning. On a 1 to 10 scale, this might be a 2. Who is my parent? X squared. This graph is going to have a parabola shape because that is the parent function. Is this function my parent function? No. It's adjusted, right? It's transformations. You guys did reach transformations last year. Okay? Where you shift left or right, up and down, and so forth. Did you guys stretch last year? Some people are shaking their heads yes. Some people are not quite sure. Okay? Have you guys did reflections? You did other things like that. It's all that type of stuff. But once again, we start from the parabola, the parent. Correct? Okay, so I'm going to start with my parent. What was he? Our goal is to graph this, by the way. And Paige is the only person. Yeah. Okay. I'm all about charts, ladies and gentlemen, because a chart allows you to go step by step and understand truly what's happening to your graph. Okay? I don't want you to do both transformations at once. I want you to do it step by step. I want you to understand what's happening to the graph, not just, and maybe not, I want to know why it's happening instead of just what's happening. Can anybody tell me what do I do here? Does anybody remember? Nobody remembers. What do you got, Wyatt?
You multiply
I would agree with that, but that's not what we're doing. We're doing transformations today, so we're just taking the graph and shifting it up, down, left, right, and so forth. So it's the same graph, but adding to, not quite adding to. Go ahead. Okay, that is a way to get a graph, but I want you to get, that's really not telling you what's happening to our graph, right? That is a possibility. Go ahead, Bella. It does. You guys remember how this shifts left to? Does anybody know why it shifts left to? And don't just tell me because you do the opposite of what you see. I've had kids tell me that earlier. Anybody know why? Why?
Well, because of the S, when you get to add 2, that means you're just going like 2 steps up from where you are in the table, so it just you get the left of 2 steps.
But so if I'm doing a +2, why would I be going left, which is a negative well? That's the thing. Why am I going left when I see a plus? Does anybody know? Or have you just always been told to do opposite what you see in there? How many of you guys got told that? Yep. Okay. Why? What value makes that 0? Isn't that more reasonable on why we're going left? Because it took us left. Notice our normal 0 was at 0. But for me to get the exact same 0 again in the y value, what did I have to do? I had to shift it where? Left 2. Because that's the value that made this guy 0 was left 2, wasn't it? Correct? Does that answer why we're shifting left 2? More than it's just opposite what we see. Right? We're actually understanding why, because it shifts it over there to get us that value at that same spot. Once again, here's kind of my parent function. Oops, that's kind of ugly, but you get the idea. So this one I'm going to shift left to. Does it have the same shape as what it did before? It does. It's the exact same graph, just shifted left 2. So what do I got to do to all the other x values? So instead of being -2, where's he going to be at? -4 instead of -1. -3. -1 and 0. What does that do to my y values though? Did my y values change at all? No, they still stay the same. It's still the same graph. It's just shifted 2, right? My arms didn't move up or down, right? They stayed the same, but I shifted. Right? With me? Yeah. So I should still have these values. If you don't believe me, what can we do? No, plug one in. Okay, plug a 0 in. What's 0 plus 2? 2 squared. Okay. Now that's not the whole graph that I wanted. That's just one part of the transformation, correct? What does this guy do? Shifts it down 1 because I'm taking these new y values that I just received after plugging this in, and then I take that value of 4, but then it's 4 minus 1, so hence why it's going to be 3. I will be shifting everything down 1. How do I know which one's the x or which one's the y? How do I know which one do I need to move? Do I move from here to here? Looking at this graph and looking at this graph, what's different? The minus 1, isn't it? So I'm shifting that graph down 1. Okay? Which doesn't mean I'm switching my x values anymore. I'm done moving those. But I will shift all my x, y values down 1. So in all be all, here's the graph that I'm looking for. There it is. So could I have graphed that a lot quicker? Yeah. Would I have been as accurate? Yeah. Kind of more of a sketch than what it is. But here I've actually plotted all the points, and I've actually understood what's happening to my graph. Notice things that are inside the function, meaning inside the parentheses, inside the function, deal with who? X's or Y's? They deal with your X's. Anything outside your function deals with your y values. You might want to write that down. Anything on the inside of your function involves x values. Anything on the outside of your function involves your y value. We're not done. I'm just don't want to make you guys wait till I'm done. You know what I mean? The bell rings or something. Yeah, both. The reason why, guys, is because I can't really make you graph all the way on the computer. Some of the problems do, but some of the problems are which one is the graph? And I can tell a lot of graphs just by understanding transformations. Like, oh, this one's moving right down. This is the only one that's right and down. Does that mean you really know how to graph it by hand? So you have 5 problems by hand just so you get the practice of it. Make sense? Okay. All right, here we go. Connor, give me any function that I just gave. I don't know if it's parent function. Which one do you want to play with? Square root of x? Okay, you want to play with square root of x. That last problem was on roughly a 2 out of 10. How about we go to a 6 out of 10? You want to try a 6 out of 10 here, Barbara? Yeah. Okay, we're going to jump up a little bit. Okay, here we go. So I have f of x equals -3 square root of -2x plus 1. Okay, this isn't the hardest it can be. The next one we'll do is we'll do the 10 out of 10 part. And that's really not too hard to do this like that. Okay? All right, here we go. Ladies and gentlemen, who's my parent? Square root of x. We're going to have that basic shape of square root of x. By the way, square root of x looks like this. Okay. Once again, those values were 0, 1, 4, 9, 0, 1, 2, and 3. Once again, does everybody understand where those values came from on the x value? Why did I pick 0, 1, 4, and 9? Because they were perfect square roots. Could I pick 7 and 3 and so forth? Can I pick negative 1? No, because I don't want to graph on the imaginary plane. I want to graph on the real plane. Okay? All right. What's next? What do you guys think is the first thing I'm going to deal with? I'm going to deal with the thing on the inside first, because order operations will say I work inside first, wouldn't I? Okay. So I have square root of negative 2x. Is that my x's or my y values? My x's, because it's on the inside of my function, right, Teresa? I heard you say that. Good job. Rafe, you doing okay? Did you put yourself an extra point on there because you love me some Robin Hood? Hey, why do you like Robin Hood? This is my baby. When I was 4 years old, my dad went to for an hour. He gave me a quarter every day to watch the monkeys. Hey, where the monkeys? No. Robin Hood, or I watched it for the you pay a quarter to watch until my sister got home. So it is my baby. Nostalgia. Okay. Does this involve my x values or my y values, ladies and gentlemen? X. So my y values should stay the same. I don't want to change them. So let me ask you this question. Riley, what value do I need to plug in for x to get me back to 0? So when I take the square root of 0, I get 0. I don't know if that made sense. One more time if it didn't. What number am I going to plug in this x value that makes me 0, so that when I take the square root of 0, I get back to 0? You know? 2 would not, because what's that? Negative 2 times 2 would give me, what do I want this result to be back at? So basically I'm making a little equation, am I not? I want him to get back to 0. So what is that x value that's going to get me back to 0? 0. That would make sense because 0 times negative 2 is still 0. Square root of 0 gets me to 0, right? A little harder one though. What value do I need to plug in for x to get me back to 1? Because when I take the square root of 1, it gives me 1, which is what I'm needing, right? So I need to do negative 2x equals 1. So what is it going to be? Negative a half. I hope this is making more sense than what I usually do in the past. How about the next one? So it'd be negative 2x wanting to know when I get to 4, right? Which would be negative 2. How about the next one? Without doing the equation. Maybe see what we're doing. Because that's how I get a result of here. So if I plug negative 2 in here, what's negative 2 times negative 2? Square root of 4 gives me, okay? What value's here? Anybody know without doing the equation? Negative 9. What did you do, Chuck?
I just said that to get to 9, you would need to
Negate it, first off.
Yeah, you have to negate it and then multiply it by 9 halves, and 9 can be divided by 2.
There we go. Notice, guys, if you ever notice, every single one of those numbers is our x values being multiplied by what number? Negative a half. Okay, think about it. Let me ask you this question. Why did my numbers go from larger numbers? Let's not look at the negatives right now, because I put the negative 2 on there. I'll show you the negative 2. Here's my square root function. Kind of like this, kind of an archie. Okay, what does the negative do? Turns me that way. It reflects. That's it. Okay, but what does that 2 do? It divides by 2. It's called a horizontal shrink. Even though he's larger, he's a big number, what's happening to our graph? It's shrinking horizontally. Because do I need as large of numbers? And once again, don't look at the negatives right now. Isn't a half smaller than 1? 2 smaller than 4, 9/2 smaller than 9. By how much? A half, because it's opposite of what we see here. Kind of like what we did up there. When we saw the -2, which way did we move? To the right 2. I don't know if we had a -2 or +2, but you get what I'm saying, right? It's opposite of what do we see? When we see it timesing by 2. So what does that do to all those values? Divided by 2. Anything on the inside of your function is your x values. Do opposite of what you see. Except for the negative, that's what they're reflected. Okay. So that is actually considered a horizontal string. What would make it stretch? Is it any fraction? 3.5 is a fraction. I mean, 3/2, excuse me, is a fraction. Below 1. Okay, so when we say fractions, we think a lot of times fractions are just below 1, but we have a lot of fractions above 1 as well. So if I did a third, what's dividing by a third? It's the same thing as timesing by 3. So instead of it being those small numbers, we need larger numbers, because when I cut it by a third, it gets back to those other values. See what I'm saying by that? A lot of people usually struggle with this step. Okay, but it's just opposite what we see. It's using those, it's taking us a lot smaller numbers to get back to these guys because I'm timesing it by 2. If I was dividing by 3, like I said, the 3x, or a third x, don't I need a lot larger numbers? So when I times it by a third, it gets back to these guys? A third times what would get me back to none? 27, right? You know, it's a larger number than what I usually need to use. 3 times as large. Because I'm stretching it horizontally to get back to those numbers. Okay? All right. Are we done with our shift? That was just our first. Yes. No, I love that you're asking a question. It was 1/3. Sorry, I put 1/3 above. Yeah, I apologize. So therefore, hence why I'm dividing by a third, which is timing by 3. Answer your question? What's next, ladies and gentlemen, the +1 or the -3? -3, because that is order of operations, right? Inside or outside of my function? Outside, so that involves my, am I going to change my x values ever again? No, because they're done, because I've done everything on this side. So these guys are going to stay the same. Okay? But I'm going to multiply all the y values by what? -3. And once again, I'm comparing the previous graph, so I'm comparing this graph to this graph. What's different? What's the only thing different from here to here? The +1. So that's all I'm doing is that piece from here to here. Notice I'm not doing multiple pieces every time, right? I'm doing a piece at a time. So I have 0, -1/2, -2, -9/2. Those are going to stay the same because once again, it's still on the outside, right? So what am I going to do to my y value? I'm going to raise them up 1. So that's 1, -2, -5, and -8. So here's my graph. Here's my parent function, by the way. Here's parent. That's what it normally looks like. Here's what I just graphed. See how it got steeper. Why did it get steeper? The horizontal shift because we stretched it, excuse me, a horizontal stretch because we multiplied it by 3, right? We did a horizontal stretch, shrink, sorry. Horizontal shrink because we put all our numbers in smaller numbers than it used to be, right? Okay. And then what do? We did reflect about the y-axis, so hence why he looked like that. Then we reflected about the x-axis, that's why he's looking down like this. Then what do? Shift him up one. Okay? Once again, we took him piece by piece and just understood who is he. Right, Myron? You're such a good boy. Like you feel. Why? Go wrestle later. I've been working out the big toe. I'm guessing not the no. Hi, Reese.
For the value, for the negative.
The y-axis. You said inside. It's the y-axis because think about just let's do this. A cubic looking like this, right? Where this, okay, so this part over here, yes, it's going positive, but my x values are positive in your view, right? And this is my y values doing negative. So if I did opposite or the negative of positive values, where do they go? And if I had negative values 9 times my negative, where do they go? So they reflect about the y-axis. The negative on the inside is the y-axis. The negative on the outside is the x-axis. If I had x squared, what does negative x squared look like? Boom. But if I had parentheses, negative x squared, looks like the same graph because I have both of them going up. Right? Does that answer your question? All right, should we do the heart of the heart?
Yeah.
Ready for 10 out of 10?
Yep.
Okay, Emma, tell me my function. Any of them except the linear one. Absolute value. This is as hard as you guys can get.
You scallywag. Let's see what you're doing.
You might want to watch this one because this one's probably the hardest one. Okay, where are we going to start? Who's my parent? So it should look like a V in the end, right? Because that's what an absolute value graph looks like, correct? I know. It's a 4. I made a 2 into a 4. It's a 4. You can make 2s. Did I show you can make 2s into a lot of numbers? Give me a number. 7. That's an easy one. What else you got? A 3. Oh, that gets a little tricky, but we can do it. No? A 9? Right, take that. Okay. Okay, here we go. Parent function, absolute value. Everybody with me there? Feel good? Okay. Once again, my Fab 5 is good enough to get us there, correct? Everybody good with my parent function?
Yep.
All right. What are we going to do next? You're saying -3? I agree with it. Does everybody agree with the -3? Because we worked our inside out? Right? Now, just because he's absolute value, we're not going to disregard him. Just bear with him, okay? Just because everybody's like, well, Mr. Roberts, the absolute value gave us 3, Mr. Roberts. Scumbags, I mean. Okay? Here we go. What are we going to do? We're going to times all these x values by what? -1/3. Not very pretty, but I'm going to. 2 times -2 times -1/3 is 2/3. Get it explained once again. Remember how we had that -2 last time? When we cut everything. Who asked that question? Was that Mr. Bear or was that yourself? Somebody in this area. Okay. Remember, last time it's always opposite what we see. We see times by 3, so I'm going to divide by 3, but I still got to have the negative. So 2/3, 1/3, 0, -1/3, -2/3. Timing everything by -1/3. Is everybody with me? Did that change my y values at all? So notice I still have 2, 1, 0, 1, 2. Does anybody not believe me? If you don't believe me, pick a point. Oh, I'm going to pick -2/3. What's -3 times -2/3? 2. What's the absolute value of 2? Oh, I'm right again. Hey, which way are we going to shift? Left, how much? Ah! That's wrong. Very wrong. I can understand why you want to pull me to the left stick, but it's wrong. I'm not trying to. Thank you for it. What did I ask you guys? Why did we shift that very first question to the left 2? Why? Once again, not because I told you to do opposite what you see, but why? What value makes it equal to 0? Right? What value makes this guy 0, ladies and gentlemen? 2. We are shifting right 2. Let me show you how you can see that. If you ever have a number here, even if it doesn't go in nicely, could you guys tell me that this is equivalent? Would you guys agree? So what's truly our shift? To the right 2. A lot of people forget that. That's probably the hardest thing for people to remember. Okay, but once again, if you remember the definition, why are we shifting in the way that we are? It's because of the value that makes it 0, right? And 2 is the value that makes this inside of my function 0. Yes, ma'am. Do you understand that this is equivalent to this? You're okay here to here? Okay, what makes this equation 0? 2. Because 2 minus 2 is 0. 0 times negative 3 is 0. You see what I'm saying by that? You good with me? Okay. So that's why, once again, understand the definition instead of just what's the trick, right? Yes, sir.
I don't get how. I'm negative 2.
Well, if I distribute negative 3 through, don't I get to a positive 3?
I'm confounded.
Okay. This is the hardest one for me to explain definition-wise. There's 2 different ways, but if I get into it, can I explain it a little bit later? Just because I think if I do it in class, I always think it makes people more confused than it helps them. But I can explain it. It's a different way of reflecting. Right now, what did I do? I actually just reflected about the what? Here's my absolute value. I times everything by a third first, right? So it's going to shrink this way. Now it looked like I just got tighter, but my y values didn't move. My x values just shrunk, didn't they? Okay? But what did the negative do? So I reflected about the x-axis. If I do this one, it reflects about, I'll show you later. I can answer it. It takes some really deep thinking. Okay? If you work this way, it just helps get more talking about the shifting of what value makes it. Okay? So is this x's or y's? X's. So I'm going to move everything to the right. How much? 2. And 2 is 6/3, isn't it? 6/3 plus 2/3 is 8/3. 7/3. 2. 5/3. 4/3. Does that change any of my y values? Nope. So here we go. 2, 1, 0, 1, 2. Does anybody not believe me? If you don't, let's pick one. 7/3. 7/3 minus 2 is 1/3. 1/3 times negative 3 is negative 1. Negative 1 with the absolute value is 1. Okay. All right. Now you might think I'm weird and all that fun stuff, but I'm teaching you the right way. Okay, what's the next thing I'm going to do? Times by -1/2, correct? So I have -1/2. I've already played with all this stuff. I can go back to him. Right? So is that the x values or the y values? The y. So does my x values change? Still the same, right? So this becomes -1. -1/2, 0, -1/2, and -1. Am I correct in that? I don't have my above, but last step, what are we doing? Sometimes on my last step, I just do this. What was my last step? Drop 4? -4, and I'll just do another chart right next to it. So I'm going to drop this y value like it's hot down 4. You guys are mean. And there he is. Does anybody not believe me? Should we check it? Because that's how you can tell if you did it right, by just plugging one of your values in, right? Okay? I'm going to try 8/3. 8/3 times, excuse me, that should be a negative here. 8/3 times negative 3. Negative 8. Negative 8 plus 6. Negative 2. Actual value, negative 2. 2. 2 times negative a half. Negative 1. Negative 1 minus 4. There it is. Okay. What's happening is you're just undoing everything. Okay? And here's our sketch. Okay, 8/3. A little bit past is at negative 5. 7/3, which is right here, is at 9/2, which is negative 4.5. Negative 4. There we go. Okay? All right. We're almost out of time. That's as hard as it's going to be, though. Now, should it take you as long as I'm taking you? No, I'm explaining a lot of the stuff, why it's happening, right? But once again, it can go really quick if you understand what each step is telling you what to do. Okay? So, really quickly, what if I told you guys had an x cubed graph? You have an x cubed function, okay? And I tell you you're going left 3, up 2, reflect about x-axis, and a stretch vertically of 4. What would be our equation? Ready? Here we go. So first off, I say y equals, oh, I don't know what, going so far over. Something cubed. I don't know if there's stuff in there or not, but I know that. Correct? Is everybody there with me? Okay, so let's start here. Left 3. Is that inside or outside? Inside. So left 3 would be what? X plus 3. Would you guys agree? How about the up 2? Where's he at? Outside, up 2. Reflect about the x-axis. What does that look like? If here's this, what's my reflect about the x-axis? Boom. Did that just happen my y values or my x values? My x values stayed the same, didn't they? The y value switch. Is that inside or outside? Outside, so the negative is here. Does that make sense? If it was reflect about the y-axis, that was like this. Is that the x values or the y values? That's the x. So if it was that, I'd do a proof like that. Because it'd be on the inside. But I'm getting rid of that because that's not what it is. Okay. And then we have a vertical stretch. Vertical, is that y's or x's? Y, so that's on the outside stretch 3. So I just have a negative 3, or 4. Okay. Did we do that? Yes, ma'am. The negative says reflect about the x-axis. So once again, Maya, that's up here, down here, right? And then you good? Those nails and pasty. Are you a nail biter? It's okay. My sister's a really bad nail biter. Like, they're down. I'm like, you are, how do you get that deep? I can barely get mine below that sucker. Do you get them deep? No? I'm sorry, I'll shut up. Last thing here. Solve for 0. I bet every single one of you guys could do this, and I didn't really have to do this, but it's on there. Would this give me all my zeros? Not necessarily, right? So I subtract 1. Divide by 2, negative 2. Take the cube root of 8. What is the cube root of 8? Say again? 2. Do I need a plus or minus? No, why? It's an odd power. And the odd powers are specific because, once again, cube root of 8 and the cube root of negative 8 are two different results, aren't they? One's 2, one's negative 2. So it's not like a square root where two numbers could give us the same thing, right? They have their own very specific form. So that's why no plus or minus. So in this case, x is negative 1. Okay? If you guys will quickly look at number 5 on your homework, is that one of my parent functions I gave you? No, but is it a function? No, actually it's not. But is it a value of a graph that I could do? What I would do is say this. Okay, if you're looking at number 5, somebody tell me. So these are the points. I always go left to right. So I have -4, -2. And then I went to 3, 3, -4, 3, 6, -3. Or excuse me, something like that. But I have the chart. Do you have a parent function? Can you shift? Yes, this is your parent function. Can you shift him the ways it tells you? Because what will this tell you to do? That will just tell us to make our x values and shift it which way? Right, 2, right? It's the same idea. It's still inside the function, right? What would this do? Multiply the y values by -3. Same idea, right? Okay, have a good one.